Hi there, Falcons. Welcome to a short DI or direct instruction about circuits. So, what is a circuit? So, a circuit is a loop made up of different components or parts that allows electricity to flow. A circuit must be a closed loop in order for it to work. Remember, the idea of electricity, it is the flow of electrons. And with circuits, we have the idea of open versus closed circuits. So, which is which? So, obviously, this is closed, right? There's no break. And this is open, right? So, a circuit can be described as either open or closed, as the case may be. And closed circuit, the circuit is operating and the current is flowing. So the light switch is on and so are the lights. Now, open circuit, there is a break here now. The circuit is not operating. That is, the light switch is off and so are the lights. Now, there are two types of electrical circuits, what we call a series circuits. The other one would be parallel circuits. So take a good look at the diagram here and this one. What did you notice? So this is kind of like one simple loop. Loop means to go around. And if there is a break, chances are this is what we call as a parallel circuit. Now with the series circuits, this one, the components are connected end to end, one after the other. So one after the other. They make a single loop for the current to flow around. If one bulb blows, it breaks the whole circuit and all the bulbs go out. So if this one blows or it breaks, then the whole circuit is affected and the whole line of bulbs would go out, right? So parallel circuit, the components are connected side by side and the current has a choice of routes or pathways. So if one bulb blows, there is still a complete circuit, so the other bulb will stay lit, which makes sense, right? So notice it goes from here, right? It encounters that, then the bulb will not light up. But from here to this one, yes, you can have light. Now, talking now about the components or the parts, right? So in a worded problem requiring you to draw a circuit diagram, the representation of the battery or the cell can be done this way. One vertical line, one long line, the other one is smaller. So here, yeah. So this is now our source of current electricity. Now, the bulb can be represented this way, like the one with the X, like this, and a circle outside, or it can be like an inverted W, the letter W here, right? A circle. So it converts electrical energy into light and or thermal energy. At times you might see the word motor in the problem. What is that? So it's a converter. It converts electrical energy into mechanical energy. And of course, you have the switch. It is open, so there is a break here, or if it is closed, right? So it says here it can be open to stop a current or closed to allow current to flow. The idea of a fuse also in a problem is represented by like a letter S here lying down, right? So this one prevents too much current from flowing through a circuit. and will break during a surge and thus will protect the circuit. The idea of an ammeter is represented by a capital letter A here with a circle. It measures current or amperage or the flow of electrons. And the voltmeter is represented by a V, capital V, and a circle around it. And this measures voltage or the potential energy. At times, you might see the word resistor, right? So just represented as a series of jagged lines here, like peaks, right? So it's a device that impedes or slows down the flow of electrons. Now, let's talk more about one of the components, the cell, right? So the cell stores chemical energy, right? And transfers it to electrical energy when a circuit is connected. Now, when two or more cells are connected together, we call this a battery. And the chemical energy inside a cell is carried by electrons from the negative terminal to the positive terminal and is used up as it pushes current around the circuit. Now, the cell, there are many types of cells or batteries now, right? Depending on the application. So there are what we call as rechargeable batteries, which can be used over and over again, and one use or the disposable batteries. Now, the chemistry inside the battery determines how many times it can be used and how long its charge will last. Now, let's study this, right? Some how do we go about the drawing of the circuit, right? So we've done this in class, but the whole idea of this short DI would be for those who were not there in class, or maybe if you were there, you are disengaged, and hopefully this will help you out. Okay, so here, if you're asked to draw a circuit diagram consisting of a 9-volt battery, an ammeter, and a 25, what's the symbol again? This is the ohm resistor in series. Include a voltmeter that is measuring the potential difference across the resistor. So here, so series. So definitely this is how you would start series. And then you have all the components one after the other. So it's easy to draw it. So you have here the battery, and then I just put there uh, the intensity of that battery or the charge of that battery, which is 9 volts. So it is in series with what? With an ammeter, so one after the other, and the resistor. So we can represent the resistor now as these jagged lines here, and then please put the power of it. So you have around 25 ohms. And the voltmeter is usually in parallel with the resistor. Okay, so this is how you represent this kind of a problem. Or this one, if you're asked to draw a circuit diagram consisting of a battery, right, made of two 1.5 volt cells. So that would be a cell, right? And here, so it is just one after the other, right? One closed switch, right? I just have it as two dots there, right? Oh, what else do we have here? Two lamps. A lamp is a bulb, right? A source of light. So two lamps and an ammeter in series. So ammeter again in series. So this is just one loop, right? And it says there show the direction in which the current flows. And usually, the current flow would be what we took this up in class. It's always between the longer side of the your representation of the cell. This would be it. The longer line would be the positive line. So notice how it flows. And sometimes even in the problem, it won't be explicitly be asked to draw the flow of the current. I would expect you to just include also the flow of the electrons, right? Or, I mean, the flow of the current, right? So here, another example here, draw a circuit diagram consisting of a battery made up of four 1.5 volts. So you can have this drawn one after the other, or you can just combine it into one set like this, right? For 1.5 volts, one closed circuit, this is the closed circuit here, and 2.5 resistors. So again, one and two, 2.5 resistors. Again, in series, right? And a voltmeter. Again, the idea of a voltmeter would be in parallel with your component, whatever that is. In the first problem, it is parallel with your resistor. This one would be parallel with your what? This is symbol, your cells or your batteries, right? So pause this part of the video and go over the diagrams here, and let's just move on, okay? So you had this on yellow paper or on a different sheet, right? And that's when we had this on the document camera in the room. And important ideas in this set of problems would be that of the voltmeter and the ammeter, right? So voltmeters are connected in parallel because they need to measure the voltage change, while ammeters are connected in series as they measure the current passing through the circuit at that point. So important information. Again, you can pause this and let the information sink in your head. Now, remember this problem. You now have a paper copy of this set of problems. A series circuit having three bulbs, one switch, and a battery. In your case, of course, I want you to always do the GRS strategy, right? Given requires solution. Now, under given, when you say, oh, you have three light bulbs, so make sure that you're able to just draw that. So under given, if I'm going to just draw it down, so I have here three light bulbs. So I can have it like this, three light bulbs, or easier would be for you to just say, oh, you have three. So you can just have it like this, three bulbs, right? What else? One switch. And it's nice to represent the switch only as this one, an open switch like this. And what else? And a battery. So I want you to just represent it this way. Lines, okay? So do it that way under given. And then required would be to draw the circuit diagram. So how would you do it? No, try it. You can pause at this time, but let me just proceed, okay? So if you have this, so let's have two different versions. It's actually the same thing, right? So here, so a series circuit having three light bulbs. So series would be one loop like this, right? So you can position it this way. Again, you can use the inverted W symbol if you want to, right? Or why not just use the X, right? I prefer the X, it's simpler, right? And of course, as always, I want you to label your components. So this is bulb one, bulb two, bulb three. And you have a battery there and you have an open switch. You have the switch here. Now, you have the positive terminals there. So electricity would flow from positive to the negative. Okay. Now you can also do it this way. wherein you have the balls one after the other. Why not? And let's have the next one. Now, again, we took this up in class. So a parallel circuit having three light bulbs, three switches, and a 3-volt battery. Again, under given, I wanted to write down three light bulbs. So you will do it this way, right? What else is given? You have three switches. So do it this way. That's the switch. What else? And you have a 3-volt battery. So you can just have one battery like this, but then the intensity or the charge on it is 3 volts. Okay, so you have something like this. So required would be draw the circuit diagram. So give it a try. You can pause at this point and do it on your own before coming back, right? Let's say you're able to do it, right? And you came back to this video. Hopefully you have the same concept of the diagram here. So here, let's see. So notice parallel. So there should be a breaks. Yes, I have here the break. And I have here the bulbs, right? Bulb 1, bulb 2, bulb 3. Of course, in any quiz, I want you to spell it out. Do not just say B1, B2, B3. So write down bulb 1, bulb 2, bulb 3, switch 1, switch 2, switch 3. And it says there, each light bulb is on a separate switch. So you can put it here or down. Yeah, why not? It doesn't matter. So long as you have the concept correct. So what else did we miss? Three light bulbs, three switches, right? And a battery. So notice how we represented the battery here. So 3 volts. This way, spread out that way. Or maybe this way. I kind of just flip over your paper so that I can visualize what you have written. There you go, right? So let's move on to the next one. Now, how about this one? A circuit consisting of a battery made up of two 1.5 volts in parallel and two light bulbs, a switch, and an ammeter. So under given, I would want you to write down two cells. So you can have it this way, two cells, right? What else? You have two light bulbs and a switch. And you have the idea of an ammeter. So all of this should be part of your given, right? Two batteries, two bulbs, one switch, and an ammeter, right? So required circuit diagram. So again, pause and do it on your own. And when you come back, compare it with this one. So let's study this, right? So it is in parallel. So there should be a break there that I need to see. So a circuit consisting of battery made up of two cells in parallel. Where is that? So this would be it, right? This part. Two light bulbs. There you go. And a switch, right? And an ammeter in series, right? So there you go. You get that? So number four. Now, interesting. So what do we have here? Three cells are connected in series. And by the way, people, yeah, I have my watch here. So here, for instance, so under given three cells, so how would you represent that? So three cells like this, and it says they're series, right? I think I forgot to write that down earlier on. So in the given, please write down the word series or parallel as the case may be. So, and then two bulbs, a circle with the X, a motor, right? M, and a switch in series. A voltmeter also was mentioned. So write all these symbols for your components. And then required would be draw this circuit diagram. Again, pause this video, try and do it on your own. Give it a try. And when you come back, hopefully you're able to figure things out this way. Okay, let's analyze this. So three cells are connected in series. So three cells, where are your three cells? This one, two, three, right? So cell one, cell two, cell three, which in turn are connected to two light bulbs. So this one connected to two light bulbs and a switch connected in series. So you notice that the switch is now connected in series. There's no break. But then a voltmeter is connected to the battery. Where's the battery side? This one, right? So a voltmeter is usually connected in parallel to the battery to measure its electrical potential or electrical energy. So pause this video and kind of assimilate the connection between the worded problem and the diagram. Okay? And of course, I have here a link. It gives me an idea or it presents us an idea of exactly what a voltmeter does, right? Hopefully, this is, yes, a voltmeter, it says here, would be what? It measures voltage or the volts or the potential energy. Okay? So number five problem here, again on your yellow paper or on the handout that I've given you earlier. So here, again, as always, given required solution, right? So under given, you draw the symbol for the components. So here, for instance, two cells. So you have two cells, and it says they're parallel. So why don't you just write down that word parallel series, right? Parallel, and then you have two cells. What else? Three bulbs, a circle with an X, and a switch, which is connected in series, right? The switch in series. And it says here, with just one of the light bulbs. So under given, make sure that you have something like this, right? Two cells or batteries there, three light bulbs, the switch connected in series with one of the bulbs. Okay? And the required is the same, draw a circuit diagram. At this point, again, pause the video, try and do it on your own. And when you come back, let's say if you have this. So let's analyze this, right? So here, for instance, So two cells, where are our two cells? Connected in parallel. So parallel, just having your mind an idea of breaking up. You break up the rectangle into n number of parts, right? So I have here two cells in parallel, right? Which in turn are connected to three light bulbs connected in parallel. So the bulbs are connected, right? Again, it can be the W or the X, yeah, because uh, th- this is one way of representing it, right? Or an easier one would be just the X, okay? So in parallel, right? And it says here a switch is connected instead with just one of the light bulbs. So one switch, right? So here, okay. Number six, let's see this one now again. Whenever you have a worded problem, make an effort to write on the given the required solution. So, given, what do we have here? A circuit with a 9-volt battery. So, you have a battery, right? The charge on it is 9 volts, right? Connected to two light bulbs. So, two light bulbs, I prefer it being drawn as the X rather than the W symbol there. And so, this is in series. But I have the motor, which is in parallel. Okay. So the circuit has a switch. Again, you have a switch there that turns the lights on and off, but not the motor. Okay. So here, try and make sure that you have this in your given, right? So we can see the cell or the battery, that's the charge on it, 9 volts, two light bulbs, the motor in parallel connection, and a switch. So part of the given. Required, draw the circuit diagram. So at this point, again, pause and try and do it on your own. And when you're done, come back to this video. Were you able to figure out this way? So in parallel, so I know that my battery, right, is connected to two light bulbs, right? And the circuit has a switch that turns the lights on and off, but not the motor. Now let's see if do we have some problem here. What do you think? Is this correct? I think this should have been what? So let me just correct that. We are on number six. What do you have on paper, people? Are you, if I'm going to just concentrate on this one, I have, this part is correct. So the circuit has a switch that turns the lights on and off. So this must be our bulb here, right? Uh, do I have three? It looks like I have three here to make this correct. So I don't want to just redraw this. So let's see. You have the three light bulbs. I think this makes better sense, right? So sometimes you have to analyze if the word that problem matches up your diagram. So even on my end, maybe that was a misprint. But I have here the bulb, right? In, is it in series? Hmm. And a motor in power. So I think, is it in series class? The 9-volt battery. Maybe I'd better have this like two. So I'm not correcting this diagram. with the problem. So let me just rewrite this. So would this make sense? Does this make sense now, people? What do you think? So I have here two connected to the three light bulbs in series. Is it in series, people? Are they in series? No. Any idea here? Is this correct? I think the solution here is not okay, right? But if we want to just, I think in your future quizzes, I want ask you to study a given diagram, try and see if it's kind of aligned with a worded problem. So sorry for this change in the worded problem, but it allows us to learn, right? And that's the whole idea of this DI. So here, a circuit with two 9 volts batteries, so this would be our battery, right? Connected to three light bulbs in parallel, so all is good. But the motor now is in, so where is the motor? In parallel. So I think I'd better just remove the idea of a motor here because there's no M that I indicated, right? I think this is much better now. The circuit has a switch that turns the lights on and off. That turns, and then maybe I can just erase this part, okay? So this is now the correct diagram for this problem. Let's try and just study this better, okay? A circuit with two 9 volts batteries. So this would be our battery. But of course, when you would be doing this, make sure that you put there 9V, 9V. Connected to three light bulbs in parallel. So this would be our light bulbs. One, two, three. And the circuit has a switch that turns the lights on and off. Okay? So here. So only connected to this battery, right? To the set of batteries, right? Okay. So let's review if it makes sense. It's connected to three light bulbs, so this are in parallel, right? The two circuits have two cell batteries connected. Hmm. You might have a different idea, right? So are you convinced that that's the correct drawing, people? What do you think? If I would try and do it, so all of you try and just grab a pen and a paper and let's try and do this, right? Start always with a rectangle, right? I have a circuit with two 9 volts battery, right? So if that's the case, the battery connected to three light bulbs in parallel. So maybe for me, I'd better just concentrate first on the battery, right? Or the bulb. The bulb is with the X, right? Right? So my bulbs are in power with each other. Now, a circuit with two batteries, right? Now, you can interpret it this way, as you said, but it can also mean that, yeah, parallel doesn't say that. Other thinking might be, Miss F, would it be okay also if I have it this way? Because it wasn't clear in the problem, right? Because this means that the two batteries would be providing energy to your bulbs here, right? And a switch that turns, so the switch should be positioned correctly, right? So I can have it this way. like the you can just have a break there, right? So this is acceptable, or you can, it's also okay to have this. Notice that this drawing, the the switch here can even be here, right? Before actually the bulb, which is what we have here, right? I hope this did not confuse you, right? So even, but I was confused when I saw the diagram. Maybe uh, there was some slight disconnect with the worded problem, right? So you can pause and listen more to our explanation, right? And let's move on to the last problem. The last problem is this. So a circuit diagram of two cells in series. So I like it when the problem would just be very clear on that. So under given, I would say, oh, series, write down the word series. And then you have the two cells, right? And connected to a fuse. Oh, this is, how do we represent the fuse here? So I have here a hyperlink, and it allows me to just go back maybe to the original setup. I don't, it says your next slide, but that's not the next slide. So let's go back to where we have the symbols, right? So here, this would be how we represented the fuse. It's just like what? The S sign, right? So that's the fuse that we have. So a fuse would be what? It prevents too much current from flowing through a circuit. Yeah, because we want to avoid any surge, right? And let's go back to a problem that we had. This one, or number 7. This one, right? And a fuse and an open switch, which both control 3 light bulbs. So in parallel. So the light bulbs are in parallel. So make sure that you allow spaces when you write down the given, right? I needed to see your thinking made visible under the given. So, and then required would be draw the circuit diagram, then pause this and give it a try. Come back to the video, and hopefully this is what you've got. Hopefully this is now correct, right? So let me just present it. So two cells connected to a fuse. So two cells in series, okay, obviously one after the other, correct? And a fuse. So the fuse is here. And an open switch. So this is now the open switch, which both control 3 light bulbs in parallel. So very clear. This is just clear as glass, right? So there you go. So there you go. I would just pause here and allow you to just process the idea on how to draw circuit diagrams. Okay, thank you guys, and good luck to any exam or test maybe on drawing of the circuits. Ciao for now.